Oh, it's Turja. Okay? Alright.
Hello. Perfect. You guys can hear me, right?
Yeah.
Awesome. So,
5, 6 minutes.
awesome. Thank you so much. Thank you. First of all, thank you to the software architecture Meetup group, right? So, and obviously thank you to the audience, right? I mean, it's complicated to be on a Saturday with this sort of events, right? Again, with all of the things and the regular weather and all. So again, thank you all of you to come in here, kind of trying to upskill yourself, and shout out to the organizing. I organize a few of this in my hometown of Kolkata. I know how complicated this stuff is, so again, shout out to all of you. So the talk that I want to focus on is, topic is reverse conveyor analysis. I'll explain what that means and how organization structure affects your architecture, right? Because again, it's an architecture meetup. So I thought this would be interesting. So brief about me, so I've been doing this for roughly 14 years. So I've worked in Samsung Research, PwC Accenture, now I'm in a Big Four consulting team. I am also part of the CNC platform working group. I do a lot of other stuff, right? And in my day job, in my office, I basically lead a platform engineering sort of a function within my organization, and we serve roughly 75K odd developers, roughly, right? That's the platform we manage, and while doing this, while determining the architecture of the platform and all, we have come up with some sort of, let's say, nuances and ideas that I have to share with all of you. Okay, again, this is just a disclaimer slide. This is me speaking, not my company and all of that. This is something my lawyers want me to always put in. So very quick agenda, right? So some context setting, because context on this, then context rule, and then reverse context, right? And how I forget some of that might help, and we'll finish with some closing thoughts. Okay, let's get started. So some context setting. So I think we are in an architecture meetup, so it's good to kind of level set on, right, what we think about architecture, right? What is architecture, right? So this guy, Grady, I don't know how many of you know, he is the person who invented UML. And UML was traditionally the language of architects, right? So we used to write and all. So he defined architecture, right, as a set of significant design decisions that shape the structure and behavior of a system where significance is measured by cost of change. It's a very complicated sort of a definition, right? Which is good if you spend time on it, but in a meetup like this, I like this definition from Martin Fowler. I think many of you almost likely know Martin Fowler. He says, architecture is a set of design decisions that must be made early. This is very important. That these are design decisions that has to be made early. Why? Why does it have to be made early? Because if you make it later, you will have a cost to pay. And at the end of the day, everything is about cost, right? We want to minimize the cost to the business. If we have a good, robust, evolutionary architecture, let's say, then we will be more flexible to change. Right? That is high level what he's trying to say. Set of design decisions that must be made early. And this guy, I also like some of his words, so he says, architecture in the field of software development are decisions that are hard to reverse. So if you now kind of combine this definition and that definition, this kind of gives us a good sort of a point of view. Why we have to make them early? Because they are hard to reverse. Because if you make them later, the farther down the line I make these decisions, the more cost I will have to pay from the system perspective, right, at the end of the day. So what do I mean by decisions, right? What are some of these decisions that we can think about? So for example, should we go with, let's say, a Kubernetes-based sort of a solution, or should we go with fully serverless sort of a model? Right, so these are design decisions. Or let's say, should I go with asynchronous-based communication using some sort of a event queue or something like that, or should I go with just synchronous API calls? These are decisions that you have to make early. Because let's say you have gone to production, and now let's say you are changing from, let's say, Kubernetes to Lambda or VM or whatever, right? It's a significant cost of change to the business, right? But at the same time, you can only make as many decisions as much of context you have when making the decision, right? You cannot think far ahead, what will happen, who knows, right? That's why we have to invest in architecture, right? That's what I feel. That if I invest in good architecture, then my system will be robust enough, flexible enough, so that in future something changes, I will be able to adjust without having to pay a large cost. Okay, this is why people invest in architecture. This is why we have solution architecture, IT architecture, data architects, all of this, right? So just in my mind, I think this is a good sort of a context of why all of us are here, because we want to build good architectures for our clients, for our businesses. And why good architecture is important? Because if I make bad architecture, pay a price for it. If I have to change it or if I have to evolve it, the price will be high. Okay. So then what are architects? Right? Okay. So then we are in a software architect meetup, right? So we are all, let's say some of us, most of us, let's say architects. So I like this diagram very much. So if you see, this person is saying from here, he's saying it's a circle. This person is saying it's a rectangle. Because that's what they see. But as an architect, our job is to see and kind of tell this diagram. You are seeing it wrong, see the full picture. The full picture, it is neither a rectangle nor a circle, it's a cuboid. So architects are supposed to, cylinder exactly. So architects are supposed to kind of provide a holistic understanding of the system. That's what we expect from an architect, right? That they will be able to understand the system, not just in a very binary term, oh, okay, I give them data, you give some output, but holistically, what are the NFRs, right? How much scalability do I want? How will the access patterns be? Right? We will ask a lot of questions, and based on that, we will come up with a 360-degree view of the system. So that is what we think are architects. Now, is architecture important? Do you think architecture matters? I think most of you think that, that's why we are all here. So this is a very nice quote, right? If you think good architecture is expensive, try bad architecture. It is more expensive. Right? So why do we say bad architecture is expensive? And again, as I said, this is how you have to communicate to your CIOs and on, because they only understand cost, right? They really don't understand, right? Asynchronous, synchronous, they don't care. We have to explain to them to a large extent that, guys, you have to invest in architecture upfront to an extent, because if you don't, then you will significantly reduce the ability of the application to evolve with time. So see, it slows down the ability of our customers to compete over time as it becomes harder to ship new features. See, code in a GitHub repository is useless unless and until it is shipped to production. That's when people will interact with it and you get some value out of it, right? So what is the main point of view? The main point of view is we should be able to move from an idea to something in somebody's laptop or somebody's mobile phone as soon as possible, right? And we know what we know, right? And we don't know what we don't know. So in future, something might change. Like let's say OpenAI is coming, tomorrow some other model will come, some image diffusion model, many things will happen. So we have to have a system that can respond to change rapidly with some sort of, let's say, ability that whenever something is changing, we will be able to kind of, let's say, respond to that. That's why architecture matters. So this is a very nice graph which shows, this is from Martin Fowler's website. So if you see, no design. So let's say there are two teams. One team has not invested in an architecture or any architecture. They're saying, okay, man, I will just do it agile. I'm an agile team. I will just come and I will just code on my own. So if you see, initially, they have started shipping features. No design, nothing, no blueprint. They have just started coding. On client repository, they have just started coding. So initially, you see, there is a good sort of a, they are, let's say, pushing a lot of story points. But over time, you see, because the design is not robust, their ability to ship new features, right? And this is actually backed by a lot of evidence I will show you. It is not like that somebody drew a graph to make their point, right? There is a lot of data behind it. But if there is no design, then what happens is, over time, kind of the ability to add new features reduces. But if you have a good design, initially you have to invest a few sprints in the design. You cannot just start coding on day one, right? So your business might be saying, what is happening? Why is not? But no, you have to tell them, guys, no. I have to invest in the design and architecture right now so that in future, I can scale as much as you want me to. So with good design, and if you see, this is the design payoff line. This is the line after which, this is the time you have to spend in a good design. After spending that time, you see the difference is starting to come. And I think all of us have sometimes, let's say, worked on a project where we have said, man, this is so bad architecture. The architecture is not robust enough, the architecture is not flexible. Could be because nobody spent time in thinking about all of the problems. And then there are so much elegant sort of code, right? You go there and you see, man, okay, this is so awesome. You really like working on that sort of code. Maybe they have spent that time. That's why they thought through the problems and the nuances of, okay, whether I should use an event-based thing or should I directly call an API, all of that they might have thought. So again, this is the high level. So with this kind of, I just wanted to set the context, right? Like, why are we meeting here? Why are we talking? So we all, I think, kind of agree that architecture is important, because if we have bad architecture in a system, the ability of our customers, our businesses to respond to change is significantly impacted. Why? because we are not able to evolve our architecture as much as we want, and we cannot respond to the changes. And if we have to respond to the change, there is a huge cost that we have to pay. Okay? So this is first section. Now with this, I will move on to the next section, right? Which is, how many of you are aware of this thing called Conway's rule? Anybody? Okay, you are aware, perfect. You are aware, perfect. So maybe anybody wants to take a stab at what you think maybe is Conway's rule? Anybody?
Maybe I think there is somewhere the kind of microservice design that you have will decide the way teams will communicate with each other.
Actually, the opposite. So what, it kind of that's actually the deeper story. So you actually kind of stole the thunder. You actually went to the final slide, but yeah, kind of what they are trying to say. See, this was Conway's law. He, I think, initially published in 1967. At that time, it was not that popular. But what he's saying is very important. Organizations who design systems are constrained to produce designs which are copies of the communication structure of the organization. What it is trying to say again? They are saying if an organization, let's say, has 5 different teams, right, spread across 5 different geographies, you will see the final design of the system will kind of mimic that organization structure with 5 different modules, one module owned by this in Argentina, another module owned by another person in China. Because your architecture is a reflection of your organization structure, that's what this guy is saying. And then there was a lot of literature, lot of work. This is basically part of a research paper. It's basically the original paper. It's interesting enough. So, what do I mean by that? So, this is something that I took from the team topologies book, if you guys have read. So, let's say I have 4 teams. Okay, I have some front-end engineers, and then I have some back-end engineers. Okay, so team A, team B, team C, team D. So, this team A has a front-end dev engineer, let's say 1, and has 1 back-end engineer. But the database admin is same. Right, so the DBA is shared across all of these 4 teams. This is interesting, right? So this guy has this team has the same DBA as this team. All of them are sharing the same database, not the DBA. Again, this is very important. I'm saying the person, the DBA. The database team is the same. I have not yet come to the architecture. We don't know the architecture. We are just thinking about the organization. So the organization is structured in this sense that every team has a front-end dev, back-end dev. So 4 teams have 4 front-end dev, 4 back-end dev, but we have 1 DBA. What will end up happening, most likely, is your application will end up also looking like this. Because those developers, front-end developer, was separated across teams, they will build their own code in their own code bases. But because the database person was the same, there's a high chance that you will end up having this single shared database. So if you see, this is the architecture that is most likely to emerge. Separate front-end and back-end components for each team, but a single shared code database. So this is what Conway is saying. Conway is saying that the architecture of the solution very closely relates or kind of links with the architecture of the organization which is designing the solution. And I think all of you have felt it maybe some way or the other, right? In some way or the other. Especially, for example, I have been working in this sort of, let's say, globally distributed teams, you will feel this even more, right? So that team, they will have their own database. So let's just site reliability engineering. So if you have a separate SRE sort of an organ, they will have their own tools in their own repository. You will have to call their APIs, kind of like they are doing their own thing with a black box. And if you have, for example, the UI and app, and let's say you have the database person also in the team. So let's say now you come up with a new pod model where every team has a UI and an app and a database there, which was not here, right? Here they only had a front end and back end, but now let's say there are 4 boxes like this. So each of them has their own separate database guide, okay, database team. Then you will most likely end up seeing that there will be 4 databases here. That's what the research is showing, okay. So the organization structure influences to a large extent the architecture of the system. Okay, this is again, as I said, right? So now coming to this microservice thought process, many people relate Conway with microservices. So what essentially they are saying is, if in an organization you have small distributed teams, right? But each of these teams is self-reliant. Okay, so let's say this team has a front-end developer, a back-end developer, a database engineer, everything. This person also has something. What will end up happening is, you will end up having modular sort of a service-oriented, or let's say microservice architecture. Because each of them will have their own sort of We call this domain-driven design and whatever, right, as sort of a context. Whereas if you have large co-located teams or huge teams, right, let's say with everybody there, you will end up with a monolithic sort of an architecture. That is what, again, is kind of like an extension of this. So if you see what the key takeaways are, right, from Conway's laws is, the coupling of teams is reflected in the coupling of their products. This is very important. Again, I am saying this is not even only in software. Even if you see, this is how we also react in life, right? Let's say when we are, let's say, organizing a, let's say, a party, or let's say even a meetup, right? If you see there are 4 people in Bangalore and 1 person, or 2 people in, let's say, Mumbai, you will end up seeing, okay, these 4 people are taking care of one part of the meetup, let's say the food and the, let's say, the gifts or whatever, and the other, maybe they're just taking care of one part. Because it's easy, right? It's very complicated to work and facilitate across a big team, right? So people kind of build their own clusters and very tightly coupled with it. So if the teams are tightly coupled to each other, then the components of the system they produce will be also tightly coupled, right? So if we are working, let's say we are very tightly coupled, I am sitting with you, all of this is very tightly coupled, right? Everything is shared, right? So let's say there is one database team, one front-end team, one back-end team. Everybody is same. Then you will see there is like a monolithic sort of a monorepo. Everybody is coding in the same place, all of that. There is no separate CI pipeline, CD pipeline. That's same. Teams build what they are tasked to build. This is also very important. That's why people focus now a lot on the architecture of teams. If you have seen some of the books like team topologies, facilitating software architecture, people are saying just understanding whether I should use asynchronous versus synchronous is not enough. That has a limit. We have to understand how the team structure is also built, because no matter how good an architecture you draw in a, let's say, a Visio or something, if your team structure is not aligned to it, it will fail. There is a chance to fail. So a database team will build a database, an electric motor team will build an electric motor. So if you have a database team and an electric motor team kind of sitting, then the electric motor team doesn't really care about the database team. Same what I'm trying to say, same thing. These guys are not talking. So this code database guy will never go and talk to them and try to understand, okay, I should have 4 databases. But if there are 4 people, 4 database people in each of the teams, automatically it would have happened. This guy would have created their own database and isolated it from the other database. Just like all of these UI guys are creating their own repositories with very less dependency, right? So this is what I'm trying to say. This is very interesting actually. And the size of the team influences the size of the product. And this is also very, I think that's why if many of you heard about Amazon, the 2 pizza team, right? Same sort of concept, right? Even in Scrum, I think they suggest 5 to 7, I don't know what was the final number, but why? Because if you want that, let's say, isolation, you cannot have a very big team, you cannot have a 100-member team writing a same code base and then expect they will automatically understand the boundaries and code in a very sort of a disparate way. It's very complicated. So big teams may produce big and more complex products. Small teams tend to produce small and less complex products. Okay? Perfect. So this is what again Conway is trying to say. So again, last thing what is, if the architecture of the system and the architecture of the organization are at odds, then the architecture of the organization mostly wins. This is also very important. So let's say you are a very nice software architect, right? You are very experienced, you build a very nice sort of a distributed sort of an architecture with full domain-driven design, very less coupling between the microservices, all of them. But if you have a central database team and you have a central front-end team, right? No matter your architecture is built in a modular way, the organization architecture will triumph over your individual architecture. Because organizations by itself are also very resilient. Right? They find a way to do what they were doing for a long time. That's why people are saying that just focusing on the architecture, just drawing a very nice distributed sort of architecture will not help. You need the organization structure to kind of align with the target architecture you want to do. And if you don't do that, there is a high chance that the architecture of the organization will superimpose on your individual architecture. Okay. So this was section 2. So this is very important to mention that your org chart heavily influences your architecture. None of us, I think, really think in this way. And we never normally think that, okay, org chart can influence architecture. Architecture will be influenced by NFRs. Architecture will be influenced by business requirements, right? How I design, what technology I choose. But actually, org chart heavily influences your architecture. If your teams are siloed, your systems will be good. It's a pattern we have seen again and again. If you really want loosely coupled and scalable systems, you must start by fixing how your teams collaborate first. This is what, there is a book called Facilitating Software Architecture by Andrew Hamilton. That book actually focuses on just this. The entire book, that guy has kind of done a lot of research on this, and he has gone to companies and he has seen that so many good architects and many things they have done, but somehow the thing is not working. And then he has kind of pinpointed that this is also, obviously the rest of the architecture is also important. I'm not discounting all of that, right? Sata pattern, everything very important and dependence. But this is also equal. So ignoring org structure is ignoring architecture. That's what Conway is kind of trying to say. With this in mind, I just wanted to take a pause and ask if anybody can guess what will be the reverse Conway manual. This is the Conway, right? The Conway was what? If my system design is X, my architecture will kind of follow that X system design. Right? That's what we are trying to say. Then what could be the reverse? Any ideas? Yes?
Yeah, the team's architecture, the team organization structure would be rely on the systems architecture.
So this architecture, the architecture that we are building should be the way that we are arranging the organization structure changes according to the architecture that you want to go with.
Yes, perfect. So kind of there told me that I can give some chocolates. So for you, can you just pass on? So yeah, so see again, I think all of us are kind of trying to say the same thing and kind of maybe hinting at it. So I will go there, right? Unless anybody has any questions or anything. Yeah, please.
I just had a question.
It's not
In this, like, when we talk about organizations of Facebook and improvements, we know that they have huge monoliths which they maintain and motivate and everything. But when we look at the organization structure, it is much more distributed. So in that case, it feels like that they have sort of figured out how to go against the organization architecture and have a architecture, system architecture, or the way that they handle the entire code base. Like much more modern.
Actually, if you see one of the very latest reasons that Mark Zuckerberg said I will hire 15,000 even I think Amazon is that they were saying they were actually not a lean organization. If you see, I will share your book from she's a PhD. She has written a book called Accelerate. Very well known, I think some of you might have read it. There she has actually researched Meta, Facebook and Google. And not research like random research. She has gone to the HR departments, understood how they hire, understand how they are structured, read and evaluated their org charts. So essentially, for example, if you see how normally many of these organizations initially were very lean. And initially when you saw, like, let's say Facebook and Netflix also has a very nice case study on Netflix also, I can share that with you. You see, initially they were very lean. So what I'm trying to say is that they actually were initially like that. So they were always initially very, let's say, disparate. So there was not a lot of monolithic sort of middlemen in between, right? So there were, for example, I think initially there were, I think, 4 or 5 levels. Then you remember Mark Zuckerberg said, suddenly he saw that there were 9 to 13 levels between him and a developer. Then he said, no, fire the middle levels. Kind of, right? That's what his solution was. I'm not saying it's a good solution, but that's what he was trying to say. So there is another also very nice sort of an architecture on, let's say for example, you see, for example in my organization, right? So many companies do that. They can come up with this sort of a central practice, a DevOps practice, an architecture practice, an engineering practice, an SRE practice. You might have seen, right? But then when you design a system, you basically borrow some of these people. So let's say I want to build an application, I will take 2 people from the DevOps practice, 1 people from the architecture practice. Why they do this? They say that centralizing the people in a practice method helps to train them. And you can share knowledge, just like we are sharing this Meetup, in a way, right? In a central Meetup, right? Why are we not doing this in every single organization? Could have done that. Your organization could have done a small Meetup, but we centralized all of the Meetups and we ended up here, right? All of architects are here at a same place. So all organizations normally try to do something like this. But then what happens is, let's say for example, there is a problem, right? So then to reach to the number of hops you have, before you can reach the top boss who can decide, is let's say 5 to 6 somewhere. So just, I don't have a whiteboard, but I could have shown that. So let's say for example, you have a team where you have an architecture lead and a DevOps lead.
You have a whiteboard there.
Whiteboard.
Okay, yeah, perfect.
On the table.
They are there.
So again, as I said, right, so let's say for example, there is an individual architect working, okay, and then there is an engineering lead. Many companies are work like that. So there is an architect, they are all working on the same product team, right? Now this architect has given a sort of an input. This engineering lead is not liking it. No, I don't care about this input, your input is bad. Now how do they solve the problem? This architect has a boss in his architecture practice. So this is a practice, okay? And this engineering practice has a practice. So this will go to his boss. Let's call him senior architect. He will escalate to his boss. This guy will go to his senior engineer. They will try to figure out a little bit tussle between them. Nothing is happening. The big boss will come. Senior architect. And then engineering lead. They will try to figure out. This has happened in every single company who has done this practice architecture. Okay? Again, this has its own values as well. The value, just a second. The value is that, as I said, right, because if you don't have an architecture practice, if you don't have a DevOps practice, and you embed all of them into your, let's say, team, let's say an individual team, then how do you share best practices? How do you avoid duplication? Right, because everybody is doing the same thing. So there is value in this, but then there is, just see how much hops they will take. 1, 2, 3, 4, 5, 6. Now imagine, there was a team, the same product has one product lead. And these two guys are working under him, the architect and the product. There is no practice, nothing. He has no boss to go. His boss is also this guy, his boss is also this guy. They will figure out in 1 second. Same task, this guy will say, no, this is correct. At the end of the day, that is what it is, right? He will say, no, the engineering lead is correct, you have to work in this way. Let's say that is the final solution. But to come to that solution, just see how many. This is what Mark Zuckerberg actually was saying to some extent. So if you see, what I'm trying to come to is that initially they were, mostly the research is showing Congress 2 is mostly bad. Now, there are some companies, for example, Netflix said we can work against it. Why? Because they hired exceptionally skilled people. So if you read Hastings' biography, he says the first rule to get into Netflix is he has to be an exceptionally talented person. They offer $500,000 salary as well, right? We all know. High. So those type of people might be able to maneuver around this. But in a normal organization, this is how it will kind of end up. Sir, you also.
Sir, having a practice of architecture or something, sometimes the things change. Say like if we have a telecom domain, so having an architect of a telecom domain, if he is in that domain, then he can understand that overall structure better. So those things sometimes are geographical area also plays an important. So how those teams are decided on how?
No, see, that's like a very complicated thing. If I could have answered that, then I would have been, let's say, start an organization myself and just consult on all of this. See, it's a very, very complicated problem. As I was mentioning, right? That's why there is not a very easy solution, like I said, right? But what I'm trying to say is that the fact that you ask this question that geography matters, that means you are kind of trying to understand that all of these things also play a role in your architecture.
Yes.
The final solution is based on all of this. We never think like that normally. Normally we think, okay, I have been given an assignment, let me create a very nice cloud native architecture. I will create a Kubernetes and this and that, CI/CD pipeline will put into. That's how we normally think, right? But there are many other things outside of, like you said, where are the architects sitting? For example, are the architect and the engineering lead sitting? That's why, for example, in my company, we try to do the PI planning in person. Many companies do that. At least the planning part, they try to do in person. They will fly the architect from, let's say, Europe to India and pay the money just for that, let's say, 1 week or 2 week PI planning, just so that people are at the same place and can collaborate. Because that is also very important. That's what I'm trying to say, right? If you see the book of Facilitating Software Architecture and Accelerate, there normally you feel software architecture in organization. I mean, it's like an HR thing, right? I have a meme also which shows, oh, then we don't need architects, we just need HR. Kind of a thing, right? Because that's how it is, right? Organization structure is really, really very, very linked to the final output, and people have understood that, and I think all of us have felt that in some way or the other. We might not have been able to fix it. Right? You will feel sometimes, okay, most of the team is in, let's say, UK, let's say US, and you are a lone architect from India. very difficult to get your point across. Right? Because the engineering lead is sitting there, he is always pushing his stuff. Whereas you are maybe coming up with a good sort of a design. So what I'm trying to say is that not how to solve it. That I also don't know, to be very fair. What I know is that what the research is showing is there is an impact. Once you acknowledge that there is an impact, then you can try to find ways to solve it, which might be different between different companies, whatever, right? So many solutions could be there.
So, which law holds good according to your discussion so far? Is it Conway's law or is it reverse Conway's law?
No, Conway's.
So, impact you mentioned, how do we know by looking at a team whether the architecture is influencing the organization or is it the other way around?
No, you did not understand the reverse. Once I go to the reverse, you will understand it's actually the same. So there is no like, is Conway's law true or reverse Conway's law? So let me go there and then I know some other people have, yeah, because then I think it will help, right? Kind of set the context. I think this one we did. So again, how many of you are aware of reverse? We kind of discussed, I'm not going to. So reverse Conway is saying, kind of like I think what you said. To achieve the desired software architecture, you should design your teams and communication structures to match it. So it's not like an opposition of Conway. It's like I'm first acknowledging that Conway is true. Conway is real. Now how can I use Conway to my advantage? If Conway is real, if we agree, all of us let's say agree based on research and whatever, right, that organization structure influences architecture. Let's say Bill Gates comes and tells all of you, and you are all agreed, fine. That's right. Then what should we do? Then we should try to fix the organization structure, because then automatically the architecture will also be influenced.
That's what you will have.
Yes, no, that's what I'm trying to say. Facilitating software, that's very complicated. See, if that was very easy, then everything would have been like, every company would have kind of done that. It's complicated. There are some, let's say, thought process around it which I will go through, right? That's like, and again, as I said, right, a software architect, that's what I'm trying to say, right? When you think of a holistic perspective, that's why you remember, right, that circle and rectangle kind of a thing, right? You can say, no, it has nothing to do with me. Let the organization design be what it is. I will just create a very nice architecture diagram with microservices and go away to my next project. They will implement it, it will happen or not happen, I don't care. Let's see. Or we can try to understand what are the different things and then we can influence it as much as possible. Obviously, we cannot solve the whole problem, right? It's a very complicated thing. This whole thing is complicated. Software architecture for distributed system itself is a complicated thing, right? We should not try to water down the complexity, right? So, to achieve the desired software architecture, you should design your teams and communication structures to match it. Let's say this is it. So, what we are saying, if we want a particular system architecture, then we need to organize our teams accordingly. If we have teams, so if you see here, the same thing I said. If I have 4 teams, if I organize my teams like that, and I as an architect can influence this at least. Let's say my boss, let's say I have been allocated to a project and my boss comes with this architecture. Or let's say this is the current design. Let's say the current design works like this, there is a shared database team. And now I have been asked to implement a microservices based architecture. Then I should go to my boss and say, man, this will not work. I should show him all of these examples and say, if you go with this model, no matter how much distributed or modular I build my architecture, the final outcome will not be what we want. So can we please separate it into this? Can I have 4 database persons, 1 per pod? And it's a very standard practice also. I'm not talking about a very complex. If you see the 2 pizza teams, one that Vogel used to say, you build it, you operate it. He used to take it a level further. He used to even include the operations guy into this. So in this case, you build it, you operate it, means even the ops is part of the product, which is even more complicated. Just imagine. After production also, the people are kind of in charge. But what I'm trying to say is that if you have this sort of an architecture, system organization, with every team has API and DB, then you will end up with a microservice-based architecture. That is what kind of the reverse Conway says. So it's not, coming to your question, man, it's not like an opposite. It's like I know Conway is there. So how can I use that Conway to my benefit? So if you see, I will go here later, but if you see here, one thing is we don't believe in Conway's laws or maybe we don't even know about it. That is one option. Many of us architects might know. We find ourselves building systems in a way that we didn't intend. Right? We will end up building something, but finally after the project ends, you will see it has morphed into something of its own. Right? Or we fight against it. We can fight against the Conway. We say, We design systems that don't align with our team structures. We fight against it. But what did I say? In this fight, organization structure will mostly triumph. So we experience high communication friction, lots of handoff and slow progress. Kind of what I was trying to show you in some extent here, right? So if you build something that is not aligned, your architecture needs to be aligned with your organization. It cannot be against. If you are against, then you will end up with some sort of friction, and I think all of us has felt it somewhere or the other, a little bit here and there, or we use it to our advantage. So this is what the whole talk of, now we are coming kind of at the end. So reverse conveyor, we know what we want to build and we design our team structure in alignment. Okay? And by structuring teams and making communication protocols explicit, we reduce the friction between teams. Again, this is not as simple as you just paste it and share it over an email to all your teams and the team will auto-adjust. There's a lot of hard work behind it. That's what those books and all of that, I'm going to show you a few of them. So if you see, again, this I will have to make it online, but this is the book I was talking about. So this lady, Nicole Ferguson, she is one of very well-known person, PhD with all of this. So she said she had led a lot of research and she calls it inverse conveyor. I called it reverse conveyor. She said inverse conveyor. Organization should evolve their team and organization structure to achieve the desired architecture. So what she did, she watched, that's something that there is research and literature which kind of proves that if you invest time and effort as an organization, right, and this is not easy, not everybody will choose to do it, but if you do it, there will be this sort of a good benefit out of it, all of this system. So that is what this person is trying to say. So again, same thing, right? So how you can implement, again, just like a 3-part high level is, think about your target architecture. Then model your organization structure to influence that target architecture. And then let Conway's law kind of take it further. So because it will automatically ensure that thing, right? But this is the part which you are saying is very complicated, right? I have written here online, model your organization structure to influence the target architecture. Is it so simple? Then it would have been a very nice thing, right? We could just send this over an email and if tomorrow, next day you come, after the weekend, our organization has already molded to do this. It will not happen, right? It's a very complicated affair. But as I said, the first thing is acknowledgement that there is something like this. Many of us might not have thought in this till some time ago, right? So if we acknowledge, that's what I said, right? If we ignore it at our own peril, if we fight against it at our own peril, if we try to use it as our advantage, at least we are trying to do something. It might be fully successful, it might not be successful, at least you can try something. Some of these things will be in our scope, which we can influence. Some will be bigger decisions. But don't think that only you are thinking. Your CIO, CTO is also thinking about some of these things. When a new CTO takes over, right, because I work with our member from CTOs all the time, these are some of the things. That's why you will see, whenever a new CEO comes, so many firings happen, so many restructuring happens. Why? They kind of try to align based on their mindset, right? Okay, this is the model design that will give me true value. That's why every time there is a new CTO or CEO assignment, you will see some very disruptive changes, right, which you normally don't expect. Okay. So key take-away message here. Let's stop pretending architecture happens in a vacuum. That is the most important thing. I as an architect, as an iBody architect, I go into my laptop, open VCO, draw very nice icons from Amazon, right, and create a very nice VPC, peering, all of that, give it to the engineering team, it will happen now. That's what we are trying to say. If you really want clean decoupled system, you have to intentionally design your teams. That is what I'm trying to say. It's a job of an architect to kind of try to influence that as well. Even if it is not fully in our control, it's our job to highlight this. We have to highlight when we see that my organization structure is completely in violation of my architecture. Then I need to go to my boss and say, man, the organization structure doesn't support this. I can still do this if you want, but the outcome might not be the best outcome that you want. If we work together and change a little bit here and there, maybe we can both come to the best outcome. That is the overall idea. Okay, so, great architectures don't emerge by accident. They emerge because the odd use was supporting them. Structure your teams like the architecture you want, or be stuck with the one your organization naturally drifts into. This is also good because organizations are huge behemoths, right? In inertia only, they will always kind of drift into their existing model. So you have to intentionally put a lot of focus And I'm telling you because I told you, right, we have designed our platform team with a lot of focus. We have been designing a platform team for let's say 6 years now. All of these structures, everything, restructuring, lot of experimentation has gone in. But I will kind of give you a few, let's say, good points to come to the next thing. Okay. So, so this is the meme I was talking about. Right, what the HR department is in charge of a software architecture. Right, kind of. That is what we are in a way. Again, I'm just in a jokingly we are saying, right? So it's a living thing. Architecture is a living thing. It's influenced by the environment it lives in. That's a very important. Right? There is a concept of ivory architect. What is an ivory architect? Ivory tower you have seen, right? That a very high tower. The architect goes into the tower, writes a lot of physio diagrams, human diagrams, gives it to his subjects as if they're subjects. Engineering teams will implement it. That doesn't happen in practice. Right? That's why ivory architects are getting fired all over the world. Right? People are saying, no, you are an architect. Come down to the actual. How many of you know Gregor Hoff? Maybe how many? Some of you might have read him. He's a very well-known sort of one, and he has a book called Riding the Architect Elevator. I suggest some of you read it. So he's saying an organization is from the engine room to the C-suite, to the penthouse. So as an architect, we need to ride the elevator from the top to bottom and bottom to top. We have a role to play at every level. At the engineering level, we cannot just come and say, from tomorrow we are all cloud native, cloud first. You can say, I am a cloud first, and then to get a backup, you have to raise a ticket. There is not cloud first, right? Or to get a VM, you have to raise a ticket. It's not cloud first. So that's what I'm trying to say. I can say many things. I can come to your organization, I get hired by everyone, I come here and say, from tomorrow, every single architecture will be microservices based. Doesn't work that way, right? So that's what we are trying to say. But as I said, to your thing, implementing organization structure change is not an easy thing. It's easier said than done, but good thing is we have some guidance. Right? With time we have some guidance. That's all we can do, right? We can learn from other people's work and try to see what part of that works. So if you see, how many of you have read the book called Team Topologies? Again, I think you have read, but very good book. That person has also read. So very, very good book. I really encourage all of you to read it. Roughly 500 rupees in Kindle or something, I think. Right? It's a very good investment. So what they are saying is, they are saying, in a modern enterprise, we have 4 types of teams. We have a platform team. This is the team that I manage in my company. We have a stream aligned team. This is mostly the team who is delivering business features. Right? So this is a stream aligned team. You have a platform team. Then you have an enabling team. Enabling team could be SI, monitoring. And then you have a complicated subsystem team. Complicated subsystem team could be the AI practice I was talking about. Very complicated thing, you don't have the expertise, you bring them in. And then there are different, I told you, right, they have coded it. They have actually worked and they have come up with the science behind the team structure. It's not abstract. So if you see, there are 3 ways of collaboration. There is a way called actual collaboration. They call it interaction model collaboration. X as a service and facilitating. So now, again, I cannot cover team topologies today because it's itself a big sort of a thing. But if you see, this is again from Martin Burke, this will kind of help. So we have a stream aligned team, right? We have another stream aligned team. See, they are collaborating, right? And they have a complicated subsystem team in middle. What that means. And finally, you have a platform team. So as I said, right, first you will have a platform team, this is a team I manage. They will kind of take care of a lot of the structure of your platform. So let's say, the infrastructure provisioning, CI/CD pipelines, all of that is being managed by them. So you have only one team. You don't need to care about any of them, you are just using them. Then you have the stream aligned team. There is the actual team which is working on the customer user story. Now when this team is working on a customer user story, let's say he needs a computer. Right? He will need some sort of a, let's say, a VM or a database or a web app or a Kubernetes cluster. He will get it from the platform team. Right? Now let's say, as I said, there is a very important model, you have to build a model or something, you have to do a RLHF, reinforcement is learning or whatever. The stream aligned team might not have the expertise. They will use the complicated subsystem team. The complicated subsystem team is kind of like a practice team. They come, they deliver that feature, work with stream aligned team, give a KT and go back. So what I'm trying to say is that these are some structured ways that you can structure your overall organization. This is actually very, very well explained in this book called Team Topologies. I don't have a lot of time to come up with, to discuss all of this today, but these are all very important.
The platform team can also be the IT services.
No, see, again, that's like, there is a very, very big difference between platform and if some of us have attended my other talks, I speak a lot, I'm part of the CNCF platform working group. They have released a white paper called What is a Platform? Just read that. first. Once you read this, what is a platform, you will automatically understand what is the difference between an IT shared service and a platform. Just give me I will give one small example because I only have 1 minute, or we can discuss later. So if you go to your standard IT shared services and go to them and say, can you give me a 1-year roadmap of what you will deliver in the next 1 year? High chance they will not be able to deliver. 99% chance. You come to me, my team, I run the platform team to an extent. I can give you a 2-year roadmap. I have it published in a. So platform is treated as a product. That is the first principle. Platform as a product. Anyways, again, I know there is a lot of tangential things, all of them interesting. We can kind of catch up later. So last thing I wanted to say that because we discussed a lot on, let's say, loosely coupled, I wanted to be very clear. I'm not advocating that everything needs to be a microservice or loosely coupled. Right? That is not my purpose. My purpose was just to use that as an example to show this. But we all know, right? Sometimes monolith is working very well, let it work. We really don't need to just force everything and make it in a microservice just because okay, microservice is cool or Kubernetes is cool. So, but it's important to acknowledge that yes, if I need a microservices based architecture or loosely coupled, I need to ensure that my system design, my organization design reflects that. And last thing, as I said, right? See, the technology we use impresses no one. The experience is everything, right? At the end of the day, nobody really cares, right? Whether you have a stream-aligned team, you have this, you have a monolithic architecture, microservice architecture, as long as you can serve the needs of the business. That's what I'm saying. Architecture is only important to respond to the customer needs in a quickly and effective manner. If, let's say, a customer comes to you and says to Turja, I need something and I will never change it ever. I will never respond to business, I just need something. I will just do, I might not even think about architecture, start coding right now. Because I don't need to think about the change. Only when I have to, that's something, architecture is not also mandatory, it is optional. I don't need architecture if the customer doesn't want architecture. Right, I can just do some code and give it to him. Right, I don't need a full thing, everything is not Google. Anyways, good. So these are some of the books I was talking about, team topologies, facilitating software architecture, the hard parts and accelerate. These are really good books. I encourage some of you to read them when you have a chance, right? And some of you
can take extra time if you like.
Sorry?
You can take some more minutes if you like.
Yeah, because of questions I will just and then we can kind of, there are some questions. So this is the thing and there are some references, right, which you can read. And again, this is the part of this one.
We will be sharing all the slides.
They will share the slides. But these are really good books, to be very clear. And this book, Software Architecture, the Hard Parts, had something because before this Neilford guy has written another software architecture book. No, Microsoft is there anyways, right?
It's part of the same series.
Exactly, this is the second one.
Fundamentals
Was a little bit, that's also very good. This is a little bit more complicated because see, we all know, right, not everything is simple, right? So when he wrote the book also, just like this guy was asking me, right, he was asking me that, oh, this is not so simple. Yes, it is not so simple. Right? It's complex and complex things need more time. I cannot come here and in 30 minutes explain a very, very complex thing and come up with an answer, then I will be a CTO of, let's say, Yahoo or Google. Right, in a way. That's what I'm saying, these things will take time. We spent a lot of time, my team spent a lot of time thinking about this thing, happy to kind of discuss any of them with you if needed. And perfect. Anything else, any questions anybody has? Yes, please.
Like one of the things that you said, it resonates with everyone, I believe that CTO, CEO joins and they like blast the teams off. So, but as a developer,
Sorry, it's just book. Oh, this I think there are links, I don't know. Okay, you can take a photo, but once you get the link, it will be easier. Yes.
So I saying like they have the luxury of doing those kind of restructuring and like to make the teams align with their what they have perceptions and all. But like I as a developer can face the same problem other way around. Like I switch between teams within the organization or I move to a new company. But I have some things that I've been, practices that I've been doing in my previous work. So how do I, maybe mold myself or assimilate the new change to new changes? How do I more flexibly do that?
See, I don't think there is a very easy. See, I will tell you, right? So one is how flexible you are as a person. how motivated you are, how energetic you are to learn. So think, not even, let's say you join another company, what would you do? You have to understand what they are saying, right? You cannot say, no, my other, you are asking all of this question because it's the same company. If it was a different company, you would not even ask the question, you would have tried to understand. But at the same time, within a company, it should not be, that's what I'm trying to say. There is a company called, I think, One Minute or something. Their CTO came in and they did an analysis, okay? I think at that time they were running 8 to 9 programming languages. So somebody was, writing, they can write it, somebody was writing .NET, somebody was doing Java. He came and said, no guys, let's kind of decouple everything, sorry not decouple, kind of consolidate everything into 2 to 3 languages. Right, so why he is doing that? Because now he wants to build expertise. Platform team is also doing. So in my team, for example, what we do many times, because I manage a platform, right, and let's say the platform has chosen, let's say Google APG as the API gateway, right? Now somebody will come to me and say, no, I want Kong API gateway, I want Ambassador API gateway, right? Because I like that, I have used it in some other project. In my last company, I used to use Kong. It is a very awesome sort of API gateway. Why are you not using it? They come to us, right? So there is different things. I am speaking a platform concept called platform convergence, but I don't want to go into that. But high level, I am telling you, there is value in standardization. So there is sometimes, let's say, it's like a very fine-grained balance. Do you want every single, let's say, I will give you a very simple example, right? So when I bought my flat, right? So if you have been Shobha and Prestige, those sort of flats, they don't let you do any customization. Inside, while buying the flat, they don't let you. You cannot say, no, I want this wall to this side. They will never do, because they are operating at scale. They are building 18,000 flats. They cannot allow all of this, right? But when I bought a flat which has only 600 units, I said, no, this wall you go here. I did that. It took a lot of time and they allowed, because they were only building 600 flats. So a startup, like you said, right, many things will happen. Somebody is doing Jenkins, somebody is doing GitLab, but then once you become an enterprise, so my enterprise has 450,000 employees, right? With 75,000 developers only that I serve. I cannot manage 20 source controls. I cannot. I have to force all of them. If that means they will lose some flexibility, And then there is an exception path where if they want, they can do, but then they will manage it themselves. So many things are there. So it's not a very simple thing, as I said, right? You have to be flexible yourself. And your company also has to kind of standardize into some tools. There is another thing very quickly I will tell you. So Spotify has a metric, right, which is called time to first commit. Sorry, time to first PR, sorry. They call it TTPR or something. So what do they measure? They measure a developer has joined your company, right? How long does it take the developer to push the first PR into production? Normally you will see, just imagine roughly how much it takes. Just imagine.
1 to 2 months.
8 to 9 months is the research. 8 to 9 months it takes a normal developer. I'm telling you guys, I'm telling you about the PR in production. Right? I'm not talking about just a small thing here and there. Right? This is how much time it takes. It takes 2 to 3 months just to understand where is my laptop. I'm just giving an example. Right? That's how IT is. Right? Enterprise IT is by default chaotic. 2 to 3 months, we always say, first 2 to 3 months, new joiners, I don't even speak to them. I know they will just let them move around here and there. After 6 months, I start speaking to freshers in my team. Because by now, at least they know where is the laptop, kind of a thing. Right? That's what I'm trying to say. So the standardization is, if I had a very good standardized tool set, so then Spotify implemented Backstage, which is the internal developer platform, and now they are saying they have reduced it to something like, I think, 4 to 6 weeks, which is huge. Right? So just imagine, 8 to 9 months you are paying the salary, and what did I say? Your source code sitting in a source control repository or in a laptop is useless to the business. It's useless. You might have written an awesome quantum computing code in your laptop, it is useless. Zero value. Unless and until it is shipped. And unless and until you raise a PR to production, you cannot ship the feature. So for 9 months you pay people, right, who are not actually delivering any value to the business. But that is enterprise, there is so much waste. But it is what it is.
I got a question, but just your opinion.
Yes.
Since you work in CNCF,
Yes.
so how all the Kubernetes architecture and everything, because of the community built around it and the architecture of community driven, also said Kubernetes, right? That's how we have all the advantage. Your comment.
See, again, I have not been I am part of the CNCF platform working group. CNCF has a Kubernetes working group as well. But once I joined CNCF, I'm telling you, I was telling somebody, I think they are more transparent than the level of transparency and collaboration they have. Is that you can write a book on it, it's more than, let's say, the government of India. I'm telling you, you will not understand what is happening there. Every election is audited. They have a chair, 3 months, everything. Minutes of meeting, YouTube videos. You want to know what decision Kubernetes took, let's say November 2023, go to YouTube, you will find it. You will find the decision the core group took, why they choose A over B, why they selected this, everything is documented. So CNCF is kind of, Linux Foundation is the epitome of open source. And open source within an enterprise is inner source. There is a concept of inner source, which is open source within an enterprise. A platform engineering team needs to embrace inner source principles. But again, that's a different thing. I don't want to diverge a lot, that's a completely different
And that time to first year also quite reduced in
Exactly.
Kubernetes community driven project.
Exactly, because see, but do you know Linux Torvald, right? Who was Linus Torvald, who was the foundation of founder, maintainer of Linux, right? How many pull requests has he accepted? People have sent so many pull requests, he doesn't accept any. Most of the pull requests they don't accept, only I think core group, 5 to 6 people he accepts, and the Red Hat people, they do something that he accepts. So there is, that's why you need a very strong maintainer group also in an open source. Because otherwise people will just put garbage. Right? People have this tendency, right? They will start putting Hacktoberfest. Have you heard about this Hacktoberfest? So in Hacktoberfest, if you raise a PR to open source project, you get a t-shirt. Right? So many people are raising PRs saying, I want a t-shirt. Documentation. Read.mp, they have raised a PR. I want a t-shirt. So this is the level of noise also is an open source. It's a very complicated ecosystem, a very interesting study to it. Yes.
So while building an application, I generally look at the scalability and cost effectiveness first. And this is a new concept that I saw today. So what would you say you would prioritize? Would you prioritize scaling and cost over the team structure, or would you prefer the team structure before?
No, I will not say it in, see, as I said, right, I might even say that I don't need any scalability if my customer is not asking for it. Not everything needs to be scalable, right? But many things you just put one VM, put a website, IIS server on that, it will run for 100 years. I'm telling you, it will never change. Most of the enterprise applications are like that. When you do an audit at an enterprise level, and we did it when our company was thinking of splitting into two, most of the things, websites are running on one IIS server, no backup, so many, the world has gone saying backup, DR, availability zone, things are running on one VM very nicely for 100 years. But that's what I'm trying to say, I'm not saying scale, I'm saying that it's completely up to the use case. I'm saying this is important to know. It's important for us as architects to think holistically, understand what is happening in the organization. Because otherwise, no matter how much you do all of these things, maybe you will not get the intended result. Maybe you will get, maybe you will not get. So scalability is obviously important. Trying to think about all of that, reliability, all of the efforts are important. But a customer will, see, customers are customers, right? They really will never come and say, okay, what is your org structure? They will never say, right? They will not even say, okay, is it scalable? Have you deployed into availabilities or so? They might say, what is your name? Punatto, I need this running all the time. That's the customer speaks. I need this running all the time. And I will say, do you really need it running all the time? Why do you need it running all the time? That is what I will ask. Then finally I will know, they don't even really need it at all. So running all the time is even, I will decommission the infrastructure first. And that's what happened, right? They have come to me on installation and finally I have decided you don't even need it. And I have decommissioned, I will not even let them go through. So I'm saying that it's a different level of thought processes.
So I had one thing. So when we talk about the Conway's model, so I think one thing that it also stresses on is establishing the right communication channels.
True.
Because that's where it says that if you're developing 4 different components, then if the teams have the right communication channel, I mean there are interaction models that are being.
I fully agree. See, again, as I said, right, if you see these 3 interaction models, I've just showed you the 3. Once you read the book, you will understand how much they have kind of thought through this. These 3 interaction models. This is one. And if you see this book, Facilitating Software Architecture by Andrew Harville, if you don't buy the book, he has a lot of blogs also. Small blogs, because reading books sometimes is a time-taking thing. Very nice blogs.
It's very costly, I checked the price.
OAD books are a little costly. But again, you can get in torrent or whatever, and anything you like that. And you handle a lot of it. Even YouTube, because many times you will buy the book, never been open it, to be very fair, right? But you can go to YouTube and just search it and you handle you will see many, and you will kind of get an idea. That is what he is talking about. Essentially facilitating software architecture. Empowering teams to make architectural decisions. There is a lot of research there. Once you think, you will think that I never knew about this. That's the kind of feeling I get when I read these books. Right? I have been doing this also for a long, long time. Right? I was doing Amazon, let's say 2012. That time many people were not doing Amazon. We had to do it in PwC because we wanted to move to cloud. But I never thought about all of these things till I entered a platform team in UI. That's when I really understood that unless and until you fix some of these things, very complicated.
Okay, platform you mentioned.
Yes. No, so exactly. See, a platform has, it's called IDP, Internal Developer Platform, but it also has a IDP called Internal Developer Portal with Backstage, essentially. It's just the portal. But you also need an orchestration engine behind it. The portal is just a front end. You can use Backstage, you can use whatever, right? So we are building the entire thing. So we have a very big platform team. We have roughly 500 odd members just in the platform team, right? And we kind of have an invest budget sometimes of $60 million just to continue building the platform every year. That is because the entire company runs on the platform.
Some IDP only exploit the infra services. For example, DB and all the CI/CD pipeline, GitHub, everything. But I think some company extend to core services. For example, I want to use a search functionality. That is also include my platform level. So that again the developer become an end user of my platform.
See, a platform's client is who? Developer. At the end of the day. So, but again, at the same time, there is a platform. So I am part of CNCF. So in CNCF, they have established a white paper. I told him about what is a platform. There is another white paper called Platform Engineering Maturity Model. You can search that very nicely. Because first day you cannot ask for $100 million to build all of this.
Yeah,
so you will have to start slow. So what are the difference? So they have split the maturity into 4 parts. Right? And now we are working, and part of the group, we are now working on an assessment framework. So we will ask you a set of questions and you can say what is your maturity based on those questions. So you go through that, then you will understand, like you said, it's like a maturity curve. Right? Day 1 you might not, day 1 you might just offer source control. Day 2, another very nice article. So I don't know, some of you have heard about Sam Newman, right, who writes a lot of monolithic microservice architecture books. So he says, a wiki page, a well-written wiki page is also a platform. Because it helps you.
Yes.
A very good documentation itself is a platform. Sorry, sir.
Yeah, just very fundamental question. Yes. That say when the project is started, you initially start with the POC or MVP, and then you land into production. So what I really face the problem when you start, right? From the architect perspective, you are always obsessed with the good code and the good tech, right? But from an engineering team perspective, he is only focused about time to market, right? So when I also showed him the graph which you showed in the first slide, right? Something similar that the production feature release will go faster if you do it from the day 1, right? But he tells me that Manish, we will not be able to reach even to that stage. Right? What if we are not able to do it because of the time? So how do you cater that mindset?
So Martin Fowler, you have heard, right? So Martin Fowler's boss in Thoughtworks was a lady, right? Who wrote a book called Building Evolutionary Architectures, right? There is a concept there called MVA, Minimal Viable Architecture. Because today, like I said, let's say you start the project and you start thinking, okay, I will put a Confluent Kafka cluster so that 10 million requests come. Even a single request does not come. Right? Maybe 5 requests will also not come.
But at least I want to set up the Kafka.
No, you are thinking like that, maybe. Right? So, what is the, that's what an architect has to think. What is the bare minimum? I said, right, what is the cost? It's all about trade-offs. Right? Just like life, architecture is a trade-off, right? So you have to understand, let's say I don't put that Kafka. What is the cost I will have to pay if in future I have to scale? So what happened? OpenAI had, Sam Altman had written a very nice blog about that. So Sam Altman's OpenAI was basically a research lab initially, right? They released ChatGPT. So initially they were saying, so when the ChatGPT released, suddenly when it kind of went crazy, right? Just like what happens sometimes with Hotstar, right? In India versus Pakistan, right? Suddenly when it went crazy, they could not react. But because they had some good architecture principles, they had not put 2000 GPUs on the day 1, right? Because who will pay for that? They don't know if anybody will log in. Right? Just like you were saying, I don't even know whether that POC will be successful. But I still need to do something. It cannot be that once the POC goes to production, I take another 2 years to completely delete my original architecture. What I'm trying to say is not simple. Obviously, there is a lot of work you have to do, but there is a thought process on this. What are some of the bare minimum items that you need to put in to your architecture without which you can, and that is that maybe has written in very, it's a very excruciating detail. What are some of the things that you should think of? See, at the end of the day, that is all we can do as architects. We can try to think of things, try to understand, okay, I have this option 1 and option 2, and then try to understand, if I choose this option, what is the cost I will have to pay? If I choose this option 2, what will be the cost I have to pay? Whichever is the least cost, I will go with that option, and I should record that in an architectural decision record, ADR. So that tomorrow if somebody comes and says, hey man, why did you choose Mongo? Why did you not choose, let's say, Neo4j? You should have chosen Neo4j. So you should say, at that time, based on the context I had, this is the thing. Now, if I have to move from Mongo to Neo4j, these are some of the things. You might say, but you might have structured your API in a way that it doesn't really care whether the backend is Mongo or Neo. I'm saying, just as an example. Okay, perfect? Perfect. Good. Thank you so much. Building evolution architectures. Perfect.